Good morning. All right, so we've got one more example to finish up in section 1.3, and then we'll get into 1.4 today. I think it's probably going to take us into Monday to finish up 1.4, so I've already moved that homework assignment into next week. So just know that you've at least got the weekend to finish up the 1.1 to 1.4 homework. It's probably going to be due Monday or Tuesday of next week, but make sure you're continuing to work on that. And let me know if you have questions, but don't put it off until the last minute for sure, because there are several questions in there, and it'll take you a little while to work through. Okay. I think that's about it. Obviously, we're not having the test on chapter 1 until we actually finish chapter 1. So that's going to be probably another couple weeks at this point. I'm trying to get through chapter 1 as quickly as we can, but I also don't want to rush through it because I want to make sure we know this information before we move on to the other stuff. Okay, we definitely need it. So any questions, comments, concerns before we get started today? All right, so let's take a look here at example 15. So what we're asked to do here is factor again. Notice, though, these are both different from the ones we've done so far, because now we actually have 4 terms that we're trying to factor. Okay, so as soon as you see something that looks like this, where there are no common factors, right? Because notice here, there's no numbers in common with all 4 terms. There's no variables in common with all 4 of your terms either. What we're going to have to do is what we call factoring by grouping. Okay, so we're going to group the first 2 terms together, and we're going to group the second pair of terms together also. I'm just going to put a set of parentheses around these 2 terms and then these 2 terms. Now, once I've created my groups, now what I'm going to do is look for common factors in each set of parentheses. So if I look at my first set there, what's the common factor between those 2 terms? Good, x squared, right? So I'm going to factor out an x squared, and now we just have to figure out what's left in that first set of parentheses. So if I factor out an x squared from x cubed, what's left over? Just an x, right? Because we would take x cubed divided by x squared. That would leave us with an x. And then what about our other term then, if we factor out an x squared? Good. X squared divided by x squared is just going to give us a 1. So we have an x plus 1 there now. Now I need to do the same thing with the other set, right? So if I look there, we have a 4x plus 4. What would be my common factor between those 2 terms? Good, right? So it's a positive 4, so I'm going to put a plus 4 here. And now what's going to be left over if I factor out 4 from each of those terms? Good, right? So 4x divided by 4 gives us x. 4 divided by 4 gives us a positive 1. So we end up with an x plus 1 there. Now, in general, when you're factoring by grouping, the goal is to get the exact same factor in both sets of parentheses here. Okay, so if I get an x plus 1 for the first one, I'm trying to get an x plus 1 in the second one also, right? So keep that in mind when you're looking for that common factor. Now, because these both have an x plus 1 in common now, that is my common factor between my terms. So what I can do is I can actually factor out this x plus 1. So I'm going to bring out the x plus 1 now. If I do that, now I just need to figure out what's left over. So if I look at this first piece here, and I factor out x plus 1, what's left over now? The x squared, right? So I'm going to have an x squared here. And now I'm going to look at this piece down here, and if I factor out the x plus 1, what's left over? Positive 4 plus 4. And then we just look to see, is there anything else that can be factored here? So can we do any more factoring with either one of those sets of parentheses now? We can't, right? X squared plus 4 is a sum of squares. Remember yesterday we said we cannot factor that any further. So this right here is the final answer. That is now completely factored. Okay, so it's not another x plus 1, right? X plus 1 becomes the common factor. And so what we're doing now is we're saying I'm going to take out the x plus 1 from each of those terms that I've boxed in there. And by factoring that out, then we just have this x squared plus 4 left over. If we think about it this way, right, so let me write it over here. If I have x plus 1 times x squared plus 4, I'm basically grouping all of this together and distributing it to each one of these terms now. And so if I do that, I'm going to end up with an x squared times x plus 1 plus a 4 times that x plus 1 also. Right? So that's why we only need the one x plus 1 out front, because it's getting distributed to both of those terms now, and that'll actually give us what we need with both of those x plus 1s. Okay. Yeah, so be real careful there, right? Because that's a common misconception, right? Is you see two x plus 1s and people write them twice. Okay, but in this case, that becomes a common factor, so we really only need it once out front now. Any other questions on that one? All right, so let's think about the second one here. We're going to do the same thing. We have four terms, no common factors between all four terms, so we're going to have to do grouping. I'm going to group my first two terms together here. I'm going to group these second terms together. Notice I kept the negative with the 9x, and I'm just going to put a little plus there to remind ourselves we're really adding all this together, right? It's not like we're multiplying there, okay, but keep the negative with the 9x. Okay, so now I need to look for common factors. Right? So if I look at my first set of parentheses, what's the common factor going to be there? X squared. Good. So we factor out the x squared. If I do that, what's going to be left over then? X minus 2. Perfect. So x cubed divided by x squared gives us an x. The 2x squared divided by x squared gives us the 2. All right, now we have to look at our second set of parentheses. What would be our common factor between negative 9x and 18? Okay, so 9 or negative 9, right? We have an option there. We have to figure out which one we're going to go with. So if we think about this now, we actually want to end up with an x minus 2 in that set of parentheses. So if I want an x minus 2, would I need to factor out a positive 9 or a negative 9? We need a negative 9. Good. So I'm going to factor out a minus 9 here, and then that's going to leave us with an x and then a minus 2, because again, distributing that would give us negative 9x, and then a negative 9 times a negative 2 would be a positive 18. And again, we're always trying to get exactly the same thing in both of those sets of parentheses. Okay, now, once we've done that, how can I now rewrite this? Good, right? So, and be careful there, that plus 9 should actually be a minus 9, right? Because that is a negative 9 out front. So we bring the x minus 2 out front, and then we're going to have an x squared and a minus 9. Okay? All right, good. Again, we only need the one x minus 2 because that is the common factor between those terms now, right? So when we bring it out, it only gets written down once. All right, now again, we always want to look and see, can we factor any further? So looking at those two sets of parentheses, is there anything we can factor more than that? We have a difference of squares now, right? So that x squared minus 9, we can actually break that down more. So what are the factors going to be for the x squared minus 9? Good. So we're going to have an x minus 3. We're going to have an x plus 3. And now looking at those three sets of parentheses, there are no common factors, nothing else I can do to break those down. So this right here now is my factored form. Okay. Any questions on that one now? Okay. So again, anytime you see 4 terms, no common factors, immediately think, okay, I'm going to have to factor by grouping. Go ahead and group the first 2 and the second 2 terms together. Look for those common factors. Try to get the same thing in both sets of parentheses there so that we can bring that out front. And once we do that, always look to see if you can factor anything else that's left over. All right, so that's it for that section. So we're going to move on now to 1.4. Okay, so rational expressions. So in general, when you hear the word rational, what does that mean in mathematical terms? Fraction. Good, right? So as soon as you see the word rational, think fraction. So everything we're going to do in this section for the most part is going to be dealing with fractional expressions, right, and how we simplify those. All right, so if we look here, the first thing we're going to talk about is the domain of an algebraic expression. So in terms of domain, we're always looking at x values. So we're trying to determine what are the possible x values, what types of restrictions might we have on our x's. Well, anytime there's an x in a denominator can't be equal to 0 because that would make our fraction undefined. And so we would have to say in this case that x cannot be equal to 0. Now, if you have more than just an x in the denominator, it's the entire denominator that can't be equal to 0. And we'll look at an example of that too. Just understand denominators can't be equal to 0. Okay, now, the next thing that could give us a restriction on our domain would be square roots. Okay, so if you ever have a square root, what can we never have inside of a square root? What types of values? Can't have negatives in a square root, right? Okay, because we can't take the square root of a negative number yet. Okay, but in terms of real numbers, we can't have negatives. That means that our x value then, excuse me, it's going to have to be greater than or equal to 0. So notice here we can have 0, right? Because the square root of 0 is just 0. We just can't have anything less than that. So everything has to be greater than or equal to 0. Right, now with this last one, now we're combining the fraction with the radical, right, with the square root. So in this case, we still can't have 0 in the denominator. So notice the only thing that's changed is we've dropped that equal sign, right? So in this case, the x has to be greater than 0 because it can't be equal to 0 because then we'd have 0 in the denominator. So in general, when we're talking about domain of an expression, those are the 3 things we're looking for. X is in the denominator, x is under a radical, or a combination of those 2 things. Okay. All right, so let's take a look at this example now, right? And we'll actually work through finding some domains. So if we look at the first one, we have 2x squared plus 3x minus 1. Right? We just want to find the domain of that expression. So again, for right now, all we're looking for are those 3 restrictions, right? So the first one was, do we have an x in the denominator here? We do not, right? Do we have an x under a square root? We do not, right? And so we definitely don't have a combination of those things because we don't have either one of them, right? So in this case, none of those restrictions are going to happen. And so what do you think the domain for this expression would be? All real numbers, okay? And so the way we can write that in interval notation, we're going to say it's everything between negative infinity and positive infinity. That would be our domain. So again, we just look at our expression, say, do we have any x's in the denominator? Do we have any radicals? If we don't have either one of those things, for right now, we're going to assume that it's all real numbers. Any questions on the first one? Okay, let's look at the second one here. So again, we go through our list. Do we have any x's in a denominator? We do, right? So in this case, what do we know that denominator cannot be equal to? Can't be 0. So what I'm going to do is I'm going to take the entire denominator here and I'm going to set it not equal to 0. We're going to say x squared minus 5x plus 6 cannot be equal to 0. So now what I want to figure out is what are the x values that would make that equal 0 so that I know which values to restrict. Well, how could I solve that now to find the x values that would give us 0? Okay, so we've got it set equal to 0, kind of, right? We can leave it as not equal to 0 because that's going to give us the restrictions. But what are we actually going to have to do with the expression on the left to be able to find those values? Okay, all right, so 5 and 6, let's make sure those are the correct values, okay? Or 5 and negative 6, sorry. Now, how would we find those, though? We need to factor, right? Okay, so let's actually factor that thing on the left, and that's going to help us to make sure we have those correct values. So what would be my factors here that would give us x squared minus 5x plus 6? And it's actually not going to come out to what I thought it was initially. Okay, so we need an x and an x, right? Because that's going to give us our x squared. Right, now we look at that last term. So what factors of 6 could we use that would also give us a negative 5x in the middle? Okay, so we could go with 1 and 6, right? So 1 times 6 would be one option. What's another option that might work here? Yeah, it could be 3 times 2, right? And depending on whether we're adding or subtracting, either one of those could potentially give us a negative 5x, right? So now we got to think about which one we want to use. Well, what do we know about our signs here? What kind of signs are we going to have? They're both going to have to be negative, right? Because we need a positive 6, but we also need a negative 5x in the middle. So I need a negative and a negative. And if that's the case, which combination of numbers are we going to want to use to give us a negative 5x then? It's going to have to be the 3 and the 2, right? So I can put the 3 and the 2. Again, the order there doesn't matter, right? The 2 could come first if you wanted to. Okay, but those are going to be our factors this time so that we actually end up with a negative 5x in the middle and still get a positive 6 for that last term. Any questions on the factors here? All right, so now we just have to think about what x values would actually make this equal 0 then, based off of those factors. So what x values will we get this time? It's going to be positive 2 and positive 3, right? Because if we take this first factor and say, well, that can't be 0, that's going to give us positive 3 for that one. And then this one over here, we say that can't be 0. This would actually give us a positive 2. And so now we have restrictions at 2 and 3. So now we have to think about how we're going to write that domain in interval notation. Well, we can have any real number we want except for 2 and 3, right? Those are the only two restrictions. So if that's the case, right, basically we're saying we've got a number line here, we've got a 2, we've got a 3. We're not including 2, we're not including 3. We can include anything else that we want to other than those two specific values. Okay? All right, so our first interval here is going to go from negative infinity up to 2. Remember, infinities always have parentheses, so we'll go negative infinity to 2. Now, is the 2 going to be a bracket or a parentheses? It's going to be parentheses, because in this case, we do not want to include 2. 2 is a restriction, so we put parentheses. Now, the next piece, right, we've got another interval now that goes from what to what? And I think Alexander's got it there, right? So 2 to 3 would be the next one. And again, we don't want to include the 2 or the 3, so we have to make sure we put parentheses around both of those. And then that last interval is going to go all the way from 3 up to positive infinity. But again, we do not want to include the 3, so make sure that's a parenthesis on that 3 also. Now, in this case, we end up with multiple intervals that work. What do we need to put between each of those intervals to show that we're including all of them? A union, right? So we're going to put a union symbol here in between each one. And so this time that would be our domain that says we're including all real numbers except for 2 and 3, right? Because that's where we're breaking our intervals, but every other real number is included. Any questions on how I got that domain now? All right, let's look at the last one. Okay, so again, we ask ourselves first, do we have any x's in the denominator? We do, right? So what do we know we can't have in the denominator now? Can't have a 0, right? So the same thing, I'm going to take x minus 5 and say that that cannot be equal to 0. So what's my restriction on my x value this time then? X cannot be 5. Good. So if I put 5 in there, 5 minus 5 will be 0. We can't have that in the denominator. Am I going to have any other restrictions on my domain this time? Okay, so what else do we have to look for? Okay, we also have to look for square roots, and we know in this case that the value inside the square root can't be negative, right? And so for this one, that square root's in the numerator, right? So this tells us that x must be greater than or equal to 0. Because I could put a 0 in that square root, I'd get a 0 in the numerator. That's perfectly fine, right? Because that square root's not in the denominator this time. All right, so those are the restrictions this time, right? We have the square root that gives us x greater than or equal to 0. We have a denominator with x that gives us x can't be equal to 5. Now we just have to think about what that domain is going to look like. So again, I'm going to sketch it on a number line, and then we'll write the interval notation. So where are we going to start this time? What's the smallest value of x we can have? 0, right? Because this tells us that x has to be greater than or equal to 0. I'm going to start my number line here at 0. 0 is going to be included this time because it's greater than or equal to. So I'm going to have a closed circle at 0. And now I want everything greater than or equal to that, except x cannot be equal to 5, right? So I know when I get to 5, all right. When I get to 5 over here, I know I'm not going to include that value, so there needs to be an open circle. Okay, so we're shading everything that's greater than or equal to 0, except 5. Now, if we were to write the interval notation for that, what would the intervals look like? Okay, so the first one's going to go from 0 to 5 with a bracket on the 0. Good, because we're including that. And then a parentheses on the 5 because we don't want to include 5. What other interval do we need now? We also need to include 5 to infinity. Good. And again, we don't want to include the 5, so that gets a parenthesis. Infinity always has a parenthesis. And then what do we have to put between our two intervals? Always a union symbol. Good. That tells us we're putting all of those values together now. So that's going to be our domain. Any questions on how I got any of that information for the third one now? And again, all you're looking for in terms of domain for right now is, do I have any x's in the denominator? Do I have any x's under a square root, right? Or do I have a combination of those two things? Those are the things that are going to give us restrictions. All right, now we want to simplify this rational expression. So whenever you're asked to simplify something like this, the first thing we want to do, okay, is look to see, can we factor? Because if we can, then we might have some like terms in the numerator and denominator that will actually cancel each other out, and then we can simplify from there. So what I want to do first, let's look at the numerator. Is there anything I can do to factor this numerator? It's a difference of squares. Good, right? And so if I factor this difference of squares now, those factors going to be? Good. We're going to have an x plus 1, and we're going to have an x minus 1. There's our first step. So now I'm going to do the same thing in the denominator. I'm going to look and see, is there anything I can do to factor this trinomial into two binomials? So what would I start with here? Okay, so we're going to have an x and an x. Then we look down here at our 2. The factors of 2 are just 2 and 1. That's my only option, so it has to be a 2 and a 1. And then the signs in this case, we want to end up with a positive x. That tells me the 2 needs to be positive, the 1 needs to be a negative, and that should be the correct factors now. Again, if you're ever unsure, right, you can always distribute it back out, use FOIL, make sure it gives you what you started with. So any questions on that step? Okay, now looking at what we've got there, do we have any common factors in the numerator and denominator? We have an x minus 1, right? So in this case, that x minus 1 over x minus 1 is actually going to cancel out now. So then all that's left is an x plus 1 in the numerator and x plus 2 in the denominator. And now this is simplified. If you ever have a rational expression and you're asked to simplify it, first look to see if you can factor. Look for those common factors to cancel out. It has to be one in the numerator, one in the denominator. They're exactly the same. And then once we cancel those out, then we'll have our simplified expression. Any questions on that one now? All right. Now we want to multiply. Okay, so we've got this big rational expression over here, x squared plus 2x minus 3 over x squared plus 8x plus 16. We're going to multiply that by 3x plus 12 over x minus 1. Now, before we do any multiplying at all, first thing I want to do is factor, see if anything cancels, and then we'll multiply, right? Because at this point, if I were to multiply all that together, it's going to be a mess in the numerator and the denominator, right? Because I've got 3 terms times 2 terms, same thing in the denominator. Let's see if anything cancels first, then we'll multiply it together. Looking at the first numerator here, what would the factors be that would give me x squared plus 2x minus 3? Good, right? So we need an x and an x to get the x squared. The only factors of 3 are 3 and 1. And in this case, the signs need to be positive and negative to get a negative 3. And to get that positive 2x, the 3 needs to be positive, the 1 needs to be negative. Okay, so there's our factored form for the numerator. Now let's look at the denominator. Okay, so what are the factors going to be that would give us x squared plus 8x plus 16? Good. We have an x and an x to get the x squared. The factors of 16 here, we could go 8 and 2, 4 and 4, 16 and 1. But to get that 8x, we actually want to use the 4 and the 4. And in this case, both of my signs are going to have to be positive to give me the 8x in the middle and to get that positive 16 at the end. All right, now I'm going to jump over to my other fraction. Is there anything we can do to factor the numerator here? Okay, good. There's a common factor of 3, so we can actually bring that out. And if we do that, that's going to leave us with an x and a positive 4. Okay. And if we look at our denominator, is there anything we can do to factor that? There's not, right? So that's just going to stay x minus 1. Now, at this point, when we multiply, remember, multiplying fractions, we multiply straight across. So everything in the numerator is going to stay up there. Everything in the denominator is going to stay down there. So I'm just going to rewrite this with the 3 out front, the x plus 3, the x minus 1, the x plus 4, over, and then down here I'm going to have the x plus 4, x plus 4, and x minus 1. Okay, so everything that was in the numerator stays in the numerator. Everything that was in the denominator stays in the denominator. Now I'm going to look for those common factors. So do I have any common factors that are going to cancel out this time? Okay, we have an x plus 4 in the numerator and denominator. I'm going to cancel out x plus 4. Notice here I can only cancel out one of the x plus 4s in the denominator, though, right? So it's 1 for 1. 1 in the numerator, 1 in the denominator. Do I have any other factors that I can cancel out? I also have an x minus 1 in the numerator and the denominator here. Any other factors that are going to cancel? No, right? So that's it. So now I know in my numerator, I'm going to have a 3 times x plus 3. In my denominator, I only have the x plus 4. This now is my final answer in simplified form. Why does it become 3 times x plus 4 in the middle? So are you asking about this step right here, Haley? Okay, so basically when we look at this numerator up here, always look to see if you have any common factors. So in this case, 3x and 12 have a common factor of 3. And so I can bring out the 3 here, and then I'm just dividing 3x by 3 to get x, and then 12 by 3 to get the 4. Okay. Does that answer your question? So anytime you have common factors, right, always look for those, because a lot of times that'll give you factors then that'll cancel out in the numerator and denominator. Okay, so always try to simplify those common factors too. All right. Any other questions there? And again, always start by factoring and simplifying, right? Don't try to multiply that out as is, right? Because it's just going to create a mess. All right. Now we're going to do some division. Okay, so we've got x minus 4 over x squared minus 4. We're dividing that by this other rational expression, x squared minus 3x minus 4 over x squared plus 5x plus 6. All right, now, in general, how do we divide fractions? Keep, change, flip. Good, right? So multiply by the reciprocal. So what I'm going to do first here is I'm going to go ahead and change this to a multiplication problem, and I'm going to take the reciprocal of my second fraction. We're going to keep the first one, x minus 4 over x squared minus 4. I'm going to change division to multiplication. Now I'm going to flip my second fraction. So x squared plus 5x plus 6 goes on top. X squared minus 3x minus 4 goes to the bottom. Now we have a problem just like the last one, right? So as soon as you see division, go ahead and change it to a multiplication problem, keep, change, flip. Now we can do exactly what we did on the last one. Right? So I'm going to go through each of my numerators and denominators, see if I can factor. So if we start up here with the x minus 4, is there anything I can do to factor x minus 4? No, right? So that's going to stay. Right? What about our denominator, x squared minus 4? Good. It's a difference of squares. It's going to give us x plus 2 and x minus 2. Okay, now we look at our other fraction. We have x squared plus 5x plus 6. What factors would give us that? We're going to need an x plus 3 and an x plus 2. Good. And then our denominator, what factors would give us that? Good. X minus 4 and x plus 1. Okay. All right. And if you don't see that as quickly, right, don't stress, right? Just take your time. Think about how to factor those things just like we did in the previous section. But in this case, those would be the correct factors. Now, it's up to you, right? On the last one, I went ahead and multiplied and put everything in the numerator, put everything in the denominator. You can actually start canceling things out at this step if you want to, because we know everything on top is going to stay on top. Everything on the bottom is going to stay on the bottom, right? So at this point, do I have any common factors that I can go ahead and cancel out? Okay, we have an x plus 2. So this one can cancel out that one. Anything else? We also have an x minus 4. Good. X minus 4 here cancels out the x minus 4 there. Any other common factors? That's it, right? And so on top now, we're left with x plus 3. In our denominator, we have the x minus 2. And we have the x plus 1. And that's our answer. Okay, so again, as soon as you see division, go ahead and rewrite it as multiplication. Look for those factors, see if anything cancels out, and then once we do that, then we can just put everything together and we have our answer. Any questions on that one now? Okay. All right, so now we want to do, all right, some addition and subtraction. So we got 3 over x minus 1 plus x over x plus 2, right? We want to combine those fractions. Now, to add or subtract fractions, what do we have to do first? We have to have a common denominator. Good. And so looking at these two fractions now, what would be the common denominator between the two denominators that we've got there? Any ideas? Okay, so let's think about this, right? If I gave you a fraction like 1/3 plus 1/4, right? So that addition there. What would be the common denominator between those two fractions? 12, right? And how would you get that? 4 times 3, right? We can just multiply the denominators together. Same thing here, right? So we have this denominator of x minus 1. We have this denominator of x plus 2. The common denominator now is going to be the product of those two things. We have to multiply them together. Okay, so if I do that, that tells me then that this first one's going to be x minus 1 times x plus 2. And this other one's going to be exactly the same thing, x minus 1 times x plus 2. Now, the question is, what did I have to multiply that first fraction by to get to that common denominator? We had to multiply by the x plus 2, right? So down here now, I'm multiplying by x plus 2. But if I do that, what else do I have to do? Good. Multiply the numerator by the same thing. So I'm going to multiply x plus 2 to my numerator also. Now in this case, we can go ahead and distribute that out. So if I distribute the 3 to the x plus 2, what's that going to give us? 3x plus 6. Good. Okay, so that takes care of the first fraction. What did we have to multiply the second fraction's denominator by? The x minus 1. So same thing, if I do that to the denominator, I have to do the same thing to the numerator. And again, I'm going to go ahead and distribute that out. So if I distribute my x, what are we going to get? X squared minus x is correct. Good. Okay. Now, at that point, now we have a common denominator. Now we can actually add these fractions together. So if I do that, I know I'm going to keep my common denominator. So that's going to be x minus 1 times x plus 2. And then I can just combine my like terms in the numerator. So if I add all that together now, what am I going to get? Good. X squared plus 2x plus 6. Now, just like before, you always want to make sure you simplify all the way, right? So we want to see, can we factor that numerator now just to see if we have any common factors. Can we factor x plus 2x plus 6? Yeah, we actually can't this time, right? Because the only factors of 6, would be either 3 times 2 so 3 times 2 or 6 times 1, and no combination of those two things is ever going to give us a 2x, right? So I know that that one is factored now. We can't do anything else with it. So this is going to be our final answer. But definitely look to see if it does factor, because if it does and you get a common factor, then you would want to cancel those out. Any questions on that one now? All right, so look at this second one. This will be the last one we do. So the first thing I want to do with this is think about how we might be able to rewrite these denominators to help us to find the common denominator. So is there anything I could do with that x squared minus 1? It's a difference of squares. Good. So it's going to become x plus 1 times x minus 1. So my first step here is just to rewrite that first fraction as 1 over x plus 1 times x minus 1. Okay, now, x plus 1 squared, what does that mean if I were to kind of rewrite it? Yeah, it's x plus 1 times itself, right? So that's going to be x plus 1 times x plus 1. I'm going to have 2 over x plus 1 times x plus 1. Right, so that's what I'm starting with. Now I need to think about what the common denominator is between those two fractions, right? So what I'm going to ask myself is, looking at the two fractions now, what does the second one have that the first one is missing, right? So I have an x plus 1 times an x minus 1. Over here, I've got two x plus 1s. What is this first fraction missing? I need another x plus 1, right? What I'm going to do is I'm going to multiply numerator and denominator by x plus 1 now. Now, the second one is missing what? The x minus 1, right? So I have an x minus 1 in the first fraction. I don't have one over here. So I'm going to have to multiply this one by x minus 1 on top and bottom. Now I have exactly the same denominator in both, right? I've got two x plus 1s and I have an x minus 1. That's my common denominator. Come over here now. I'm going to have my x plus 1, x plus 1, x minus 1 is my common denominator. And now it's just a matter of actually distributing this out, right? And then combining like terms. So what's 1 times x plus 1 going to give us for that numerator? Okay, so 1 times x should give us x. 1 times 1 should be 1, so we just get x plus 1, right? Because we're just distributing 1 each of those terms down. Now, be careful with this next one. We're really distributing a negative 2, right? Because we're subtracting this. So if I distribute that negative 2 to each of my terms, what will that give us? I have a negative 2x. Good. And that negative 2 times negative 1 becomes a positive 2. And then my last step is just to combine like terms up there. And so once we do that, what should we get in the numerator? Okay, so x plus 1 and then minus 2x plus 2, combining like terms will give us what? Okay, good. So we have a negative x and then a plus 3. All of that now is over x plus 1 times x plus 1 times x minus 1. And again, there are no common factors, nothing else I can simplify here. So this right here is my final answer. Okay. So I know we're out of time, so if you need to go, you can go. I'll hang out for a couple more minutes in case there's any questions on that one. Again, continue to work on homework. Let me know as you got questions on that. But have a great weekend, and I will see you all on Monday.